Alright, this is Module 5 practice test. I'll go over every single question. If you have any questions on anything, just make sure that you contact me. If you feel like I'm going a little too fast, just remember this is a recording, so you can always pause, get yourself caught up, and then start again. Alright, for questions 1 through 17, we're supposed to factor the polynomials if we can. Alright, so number 1, when I look at that, I see that something can come out of both of the terms, so that's what you always look for first. In this case, I see 15. So that's what goes outside the parenthesis. What goes inside is what's left. So if we take 30x and we divide by 15, we're left with 2x. We take 45 and take out 15, we're left with 30. I'm sorry, 3. Alright, so you can always check yourself by multiplying and it should come back to the same. Just make sure that these are in lowest form, because you could possibly not take out the lowest thing and then your polynomial is really not factored completely. Alright, number 2, if I look at all my terms, I can take a 5 out, and I also notice an x squared. The largest x I can take out is squared, because if I take out any more, this one will be short. And they all have y's. So my first term, if I divide 30x4y by 5x squared y, I'm left with 6x squared. My second term, I'm left with 3x. And my last term is divided by itself, which means we're left with 1. Always check to make sure that what you have left in the parentheses cannot go any further. If it can, then you need to start over and take out the larger. Alright, number 3 is factor by grouping. If one set of your parentheses is the same, that is one set of parentheses. What is left is your other parenthesis. So this can be written this way too. Alright, number 4, I look at all 3 terms and I don't see anything that they have in common, so here is where we multiply the 2 together and I get 15, and we're looking for factors of 15 that add together to give us negative 16. So if I just start writing out the factors that I know for 15, I know that some kind of combination can give me 16 if I use 1 and 15. They both would have to be negative, because that's the only way I can get a negative 16, but when we multiply those, we will get a positive 15. Alright, so when you find the factors that you want to use, rewrite the middle term with those factors. So instead of writing negative 16y, I'm going to write negative 15y, negative 1y, so the inside looks different, but it still means the same thing. The reason we do this is so we can factor by grouping, like what you saw in number 3. So I'm going to factor this. So I took 5y out of here and left with y, 5y out of here and left with 3. If I take out a negative 1, I'm left with a y and a minus 3. So our goal is to have one set of parentheses the same. When we do that, then we have successfully factored by grouping. Now if you like the test and guess way, I won't do it, but I can go over it real quick. You know that you're going to have 2 sets of parentheses. You know that the first numbers in those parentheses will equal 5y squared, so you can either write 5y and y, or y and 5y, and then you know your last term here has to multiply together to give you 3, so you're either going to write 1 or 3, or 3 or 1, and then the right combination, you'll have to FOIL it to make sure that you get the correct answer, because it does matter which way, which direction you write them. I don't like the test and guess way. It takes too long for me to test and guess. All right, number 5. I look through, I don't see anything that can come out of all of them, but I do see that I could group them as such and be able to take stuff out. Now by grouping, we're hoping to get a set of parentheses that is the same. Otherwise, it didn't help us at all. Alright, so this first one, I can take out x squared. I'm left with x plus 3. So hopefully when we do the second part, we'll have a parenthesis that is x plus 3. So if I take out 2, I'm left with x plus 3. So we were successful. And remember, you can also write these in the flip-flop order, so you could have this one first and this one second, doesn't matter. Alright, number 6. We can group these. I couldn't see anything that came out of all of them, but if I group them, I can see stuff that can come out of each one. Alright, so the first one I can take out x, and I'm left with y plus 4. The second one I can take out a negative 2, and I'm left with y plus 4. So that was our whole goal. If we see that set of parentheses that's the same, then we were successful. Alright, number 7, I can't group it. There's nothing that can come out of all. So this is the one where you would want to look at your last term and find factors of 2 that multiply together to give you 2, and add together to give you 3. So if I'm thinking about 2 and 1, well, 2 times 1 is 2, but 2 plus 1 is positive 3. But I've changed these both to negatives. Negative 2 times negative 1 is 2. Negative 2 plus negative 1 is negative 3. So that's the factors we want to use. So we'll make our parentheses. The first part of our parentheses is whatever this is broken down. And then what we found for our factors that worked for the multiplying and adding part will be our last part, and then the correct signs that go with it. Alright, number 8. There's nothing that can come out of all. I can't group it because there's not enough terms to group. So I'm going to have to do like I did on number 7, where I'm thinking, well, what can multiply together to give me 8 and adds together to give me 6. So I'm thinking 4 and 2 at first, but when I do that again, it's going to have to be negative. And then we also have this extra y squared on the end. So that means that when we make our parentheses, that we want a y at the end here. So we want negative 4y and negative 2y. Alright, number 9. Nothing can come out of all, so now we're trying to find something that multiplies together to give you negative 9, adds together to give you 5. Well, these are the only factors of 9. So no matter what I do, I will never add these together and get 5. So this is actually a prime. It cannot be factored. It is already in its factored simplified form. Alright, number 10. If I look through here, I can see that I can take out 3 from every term, and I can take an x out of every term. And I'm left with such. Now when you do that, you always want to make sure that this can't be factored, which multiplies together give you positive 11, adds give you 12. We think of 11 and 1 again, negatives. So we have negative 11, negative 1, and then don't forget your 3x out front. So number 11, when you have a coefficient out here, we can't do something as simple as what we did in number 8, where we're just looking for something that works with these two. So we have to actually look at it this way. So we're looking for something that multiplies together to give you positive 32 and adds together to give you 33. So I'm thinking 32 and 1 would work. So I'm going to rewrite my middle term so that it still equals the same thing, but now I'm able to group it. Now sometimes you'll have to rearrange and put stuff that will actually factor with the person that it is with. So if I had written this the other way, well, it still would have worked. It would have looked a little different. Okay, so this one I can factor out an 8x, and I'm left with x plus 4. This one I can only take out a 1, and I'm left with x plus 4. So our whole goal happened, and what's left goes in the other parenthesis. Alright, number 12. So we're looking for something, because I can't take anything out of everything, so it has to equal 30 and adds together to give me 17. So I'm thinking 1 and 30, 2 and 15, so bingo. So I don't always know it off the top of my head right away, so I always start listing off my factors. So 2 and 15 will work. Both will have to be positive. So I'm rewriting my middle term. And I'm going to flip-flop these because I like how 15 goes with 5 and 2 can go with 6 much better. So just I kind of pay attention to who they're getting grouped with as I'm writing it. Group it. Take 5y out of the first one. Left with y plus 3. Take 2 out of the second one. Left with y plus 3. And I got my 2 sets of parentheses. Alright, number 13 is the sum of squares, which means this is a perfect square and this is a perfect square. So whenever that happens, you have 2 sets of parentheses, one with a minus in it, one with a plus. We, for lack of a better term, unsquare our first thing, so 2x and 2x, and then 1 and 1. Number 14, I can take 2 out of it. When I look at this, I see a perfect square again. Perfect square, perfect square. So we're going to have 2 sets of parentheses, one with a minus, one with a plus, and then we unsquare, or take the square root. Number 15. I see a perfect square and a perfect square here. Yeah, we're gonna have to go this direction. So 16 times 25 is 400. So we're looking for something that multiplies together to give us 400, adds to give us negative 40. So let's see what we can find. So we just start listing them. So far these are all too big, but we're getting closer. 8 and 50. Oh, no, I didn't see. This one's got me stumped. And we could do 10 and 40. 11, 12. Get 16 and 25. Getting closer. Oh, that was a silly one. Didn't even dawn on me right away. So it just shows I'm human and we all struggle through the same thing. So 20 and 20, these would both have to be negative. So I'm going to rewrite my middle term with negative 20x, negative 20x plus 25. Now we're going to factor. So we can take out 4x out of both of those. And I can take out a 5 out of both of those. And yay, it worked. And this time we have 4x minus 5 and 4x minus 5, so 4x minus 5 squared also is a good answer. So it just kind of shows you, the thought process. Keep going until you find those numbers. Sometimes they don't dawn on you right away. I don't know why that one didn't. Alright, 16 is the difference of cubes formula. So you have two sets of parentheses. The first one is this one uncubed and this one uncubed. So try to think of what times itself equals that number. And then what's left is you'll square your first one. You'll put your next two together. And there's always pluses in the second, so 3 and x. And then you square the last one. And then 17 is the difference of squares again. But on this one, you want to be careful because this one is also the difference of squares again. And then don't forget to put that guy that didn't get factored again. Number 18 says use the zero product property to solve. So that just means that you're going to set things to 0. So this one will get set to 0 and this one gets set to 0. So we have two answers here. We have 0 and negative 12 as our answer. Oh, that should be positive 12. Sorry about that when I brought it to the other side. Alright, so this doesn't need to be set to 0. Only the x's that are being multiplied. So this doesn't have to be done. But that one would be set to 0. And that one be set to 0. So we get a positive 7 here. And a negative 9/4 here. So there's our two answers. Number 20 says use factoring to solve each quadratic equation. So we're going to find something that multiplies together, give you negative 14, adds to give you 5. So right away 7 and 2 come to mind, but this one would have to be positive and this would be negative. So to solve these, now we would make the zero property so that we can actually get an answer. So we get negative 7 and 2. This one we need to bring that 8 over and then factor. What multiplies together to give you negative 16 adds to give you 15, so it's somewhere with 15 and 1. So to be negative but positive in the, oops, sorry, 16 and 1. This would be a negative, this would be a positive. Then we're going to group it. And then I have, oops, sorry, 2x minus 1 and x plus 8, and then we need to set both of those to 0. So the difference between what you're doing here and what we did on the front page is here they actually want an answer. What makes that problem true? The other one we're just factoring. So we get a half and negative 8. So on here, we're going to have to FOIL first. Bring our 50 over. Combine these. If we bring 50 over, then we have minus 56. And then we're going to factor. So this would be x, and we'd have 8 and 7 would be 56. We need it to be negative and then positive. So this would be positive, this would be negative. We set this to 0. We get negative 8. We set this to 0. We get 7. 23. Bring everything all on one side. Factor. Set both to 0. So x can be 5/3 or 0. Alright, last page. A ball is thrown straight up from a rooftop 300 feet high. The formula h equals negative 16t squared plus 20t plus 300 describes the ball's height above the ground, h in feet, t seconds after it was thrown. How long will it take for the ball to hit the ground? So what you're finding here is what your x or your t value is, so we're just going to factor this. The 300 is already integrated into the problem, so you don't need to make it equal to 300 because it's already in it. So first thing I would say, let's take something out. So let's say 4, well, just 4. And I'm left with negative 4, 4t squared minus 5t minus 75. So we're looking for something that multiplies together to give us 75 times 4, which is 300, and that would be a negative, and then adds to give us negative 5. So we're going to do 1 and 300, 2 and 150, 3 and 100. So obviously it's going to be numbers that are pretty close together. 4 and 75, 5 and 60, 6 and 50, 7 and 8. So we are getting closer. 12 and 25. And I think it just found it. 15 and 20. So this is our winner, and we need it to be negative in the middle and negative at the end. So I'm going to rewrite my middle term. So this still equals 5. Then we're going to group it. Take out 4. 4t. And take out 5. Take out 15. And we're left with t minus 5. So we have 4t plus 15, t minus 5. So we can set each one of these to 0. When we do this, we're left with a negative, so there's no such thing as a negative time. So we'd automatically eliminated this one, so our answer is 5 seconds. Alright, 25. A shark has a triangular tooth with a height that is 1 centimeter longer than the base. If the area of the tooth is 50 square centimeters, find its base and height. Alright, so first we need that formula for a triangle. And we're going to define our base and height in terms of x. Usually what they say last is your x. So height says it's 1 centimeter longer than the unknown base. So then I'm going to plug it back into our formula. And we could just multiply these together. So I just multiplied those. Now I'm going to multiply these. I don't like fractions, so I'm going to multiply everything by 2 to get rid of them. I'm going to bring this over. And then I'm going to factor. Oh, wait a second. Am I missing? Oh, wait, these can go together. I'm missing an x somewhere. It's here. There we go. And then I can factor this. So we want it to be 30 and 1, so it's 6 and 5. We need the middle to be positive. So again, if I set this to 0, I get a negative number. There's no such thing as a measurement that is negative. But the other one would be 5. So my base is 5 centimeters. And then I add 1, and I get 6 centimeters. So we use what we defined at the beginning. Alright, have any questions? Please let me know.